Well, hello everybody, and let us continue with our discussion of naming. And we have talked about naming molecules, and we've talked about naming ions, and now let's get into a subset of naming molecules, and that is consider HCl. Is this an oxyacid or a binary acid? Okay, so we want to talk then about what? Naming acids. So if we look at our naming, just to show you where we are in our concept map, and we had ions over here, right? And we have compounds over here. And we broke compounds into ionic and molecular. And one subset of my molecular is the category of acids. So we want to talk about naming acids. And the first thing I think we always like to do is what? Let's define what is an acid. Well, there are several definitions, and we want to learn the Arrhenius definition. And later in your life, you'll learn about the Lowry-Bronsted and the Lewis definition, but we only care about the Arrhenius. And here's what the Arrhenius definition is. An acid is a substance which increases the concentration of H plus when dissolved in water. And we don't know really what concentration is, but just think about it as this. It's a substance which increases the amount of H plus. So we can put in, instead of concentration, amount for the time being until we learn concentration. A substance which increases the amount of H plus when dissolved in water. And the general form for this is going to be H and then X, where X is a nonmetal. And usually, most of the time, in fact, X is a halogen. Not always, but usually. And we might have one or two depending on the charge of our nonmetal, how many protons at once. But most of them have just one H, and there are things like HCl, H2SO4. These are examples of, oops, you know what? I got a little ahead of myself. Let's skip that for a second. I got to my binary acids too soon. But most of these, yikes, look what happened. Most of these have H in them. So like HCl would be correct, H2SO4. These are both examples of Arrhenius acids. Now, I kind of tip my hand because there are really two types of Arrhenius acids. There is, isn't that a beautiful blue, by the way? We have binary Arrhenius acids, and we have oxy acids. Good. And so what is a binary? A binary Arrhenius acid is an acid composed of what? Composed of only two elements. And here's where I got ahead of myself. Usually that is H and a nonmetal, and most of the time that nonmetal is a halogen. Most binary acids are an H and a halogen, like HCl, HBr, HF. These are all typical binary acids. Now, what's an oxyacid? An oxyacid is an acid composed of H plus an oxy anion. Aha, do you guys remember what your oxy anions were? Well, those are my polyatomics containing oxygen. Things like PO4 3 minus phosphate, SO3 2 minus sulfite, NO2 minus nitrite, C2O4 2 minus, which is oxalate. These things plus hydrogens on them become oxy acids. And notice we need as many hydrogens as you have a negative charge. So if I have a 3 negative charge, then I have H3PO4, H2SO3, HNO2, H2C2O4. Now this thing actually does have other forms. H2PO4 minus, that is also an acid. So we won't get into this one yet, but that is an acid. We'll focus on our acids, which are not ions, but complete molecules. Okay, so those are the two types. Let's go back to our question and let us see what it is. HCl, is it an oxyacid or a binary acid? Well, how many elements do I have here? 2. 2 means binary. That means this is a binary acid. Good. Consider hydrochloric acid, chloric acid, and chlorous acid. EGADs. Write the formula for each. Wow, they all have like chlor in it. I wonder, is there a way for me to figure out the difference? Well, when I look at that, what do I notice? One of them has what? One of them has a prefix. This one has no prefix but ends in ic. And this one has no prefix and ends in us. Well, do you suppose that is a point of differentiation? And actually, it is. Let's go back to our acids. Let's look at our types. And let's talk about naming. Over here, let me erase this so we have some more space. Yeah, magic. Woo! Isn't that cool? And I'm going to have to change my color again. Doink. 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 Okay, we're talking over here on the left side about binary acids. Here's binary acids. And we're going to talk about naming of binary acids. Naming binary acids. Okay, how do we name a binary acid? So naming binary acids. Okay, first thing we do is it takes a prefix. The prefix is always hydro. Always hydro. Then we add, we have the stem, and we add the prefix to the stem, and then we add a suffix, and the suffix is always ich. Ich. Started to get some German in there. So it's hydro, stem, ich. For instance, hydrochloric acid, right? HCl. Since it starts with hydro, that means it's binary. It only has 2 elements in it. One element is going to be hydrogen, one element is going to be chlorine, and it always ends in ic, hydrochloric acid. In contrast, let's come down here and let's have our little arrow talking about naming oxyacids. Oxyacids. First rule in naming oxyacids. Number 1, no hydro. Zoink, no hydro. If it says hydro, then it cannot be an oxyacid. So that means there's no hydro. Number 2, we have 2 choices for suffixes. And the suffix depends on the suffix of the oxy anion. Okay, so that means I look at the oxy anion to determine my suffix for my acid. Remember, my oxy anions end in either ate or ite, right? Like chlorate or chlorite, right? So if it ends in ate, if my anion ends in ate, then my acid ends in ic. If my suffix on my oxyanion ends in ite, then my acid ends in us. All right? So that's all there is. So we'll take a stem, and then we'll not steam. We'll take a stem and add a suffix. And the suffix is either ic or us. All right, here we go. Hydrochloric. Well, it starts with hydro. That means what? It has to be binary. If it's binary, it has two things in it, H and whatever here, HCl. Good. Chloric. Okay, there's no hydro. That means this is an oxy. If it's an oxy, we have to look at the stem here. Stem is ic. On my acid, the acid ends in ic. That means my oxy anion ends in what? 8. And so that means my oxy anion would be chlorate with some hydrogen on it, right? Because it's always a hydrogen plus, so it's hydrogen plus chlorate. What's my formula for chlorate? ClO3 minus. If it's 1 minus, how many hydrogens do I need? 1. So it'd be HClO3 is the formula for chloric acid. All right, no hydro here. It ends in us. That means it has to come from an ite. And what is the ite? Well, it's going to be chlorite. Chlorite. And what is chlorite? ClO3. Oh, no, oink. ClO2 minus. Has 1 minus. How many hydrogens do I need? I need 1 then. HClO2. So that is chlorus acid. Okay, it's a little bit complicated, but I think you guys can handle it. All right, you tell me if each of these is an oxy acid or a binary acid, and then you name them. Pause me and bring me back when you're ready. All right, here we go. HF, how many things do I have there? Well, I have H and I have F. That means this is going to be, what? Binary, that is correct. Binary. And put some feet on him and give him a big foot, and it's Friday, so we're going to say, yay, big smile, a little bit of my hair on the top, lots of hair on the side. I don't know what those things are. Okay, but it's a binary acid, and when I name a binary acid, what am I going to start with? I start with hydro, and then stem, fluor, and what do I always end with in a binary? Ic. Hydrofluoric acid. There we go. Cool. Now, H2SO3, well, I have 3 elements, so that would mean that this must be an oxy acid. That means, first of all, no hydro. So I want to focus on my oxy anion. This oxy anion is what? Well, it's SO3 2 minus. What is SO3 2 minus? SO3 2 minus is sulfite. What is the suffix? Well, it's ite. When I use ite, what is the suffix on my acid? Well, it's us. So it's going to be sulfurous. And do I put a hydro there? Nope. I just put the the acid. So I have my stem and my stem and my suffix, sulfurous acid. And then the last one, 1, 2, 3. Good. That means it is not binary. It's oxy. NO3 minus. What is NO3 minus? It is nitrate. Boy, I certainly hope I've memorized all my polyatomics. If not, I'm in trouble. Yes, you are. Good. If it's nitrate, what acid ending do I use? If it's 8, I use ic. Nitric acid. There we go. Nitric acid. Those are our 3 names. Moving on. Oh, cool. Now we're going into CuOH2, copper. Well, we'll be quiet. I don't want to give you the answer here. Name this base. All right, so now we want to talk about bases. So here's our beautiful picture. We've got molecular. And you know what? Bases are a form of ionic compounds. So we have bases here, and we want to talk about what is a base. Well, according to my Arrhenius definition, it is a substance which increases the concentration of not H plus, but OH minus when dissolved in water. Okay? So usually with my bases, they take the form of a metal, and maybe one or two, and then an OH, excuse me, metal like that. I have OH in my formula. I have a metal, and this X depends on the charge that I would have on my metal, right? So something like sodium hydroxide or zinc. Zinc is always plus 2, right? So I need 2 hydroxides. Good. So that is my base. And the cool thing here, and I'm going to just kind of zoink. Naming. How do we name? Naming bases, by and large, all we care about right now is same as any other ionic compound. Hey, they're just normal they're just ionic compounds that have OH in them. So I name them the same way I name any other ionic compound. Sodium hydroxide, zinc hydroxide. Yay! Nothing new, Mr. Smith? No, nothing new about naming bases. Good. So if I have CuOH2, what do I have to do? Well, I have my copper. Copper we know is in the D block. So what's the charge here? Well, I have 2 OHs. Each OH is a -1. I have 2 of those. So what's my total charge over here? 2 negative. So I have to have a what here? A 2 positive. So that means I have copper 2 what? Hydroxide. There we go. That's all there is to naming bases. Last one, and then we are done. Aluminum hydroxide. What is the formula for this base? Pause me and bring me back when you're ready. Oh, this is easy. I can't believe, Mr. Smith, you're letting me do this. Aluminum, right? What's the charge on aluminum? Aluminum is a what? +3. Hydroxide, -1. What's my least common multiple? 3. How many aluminums do I need to get to a 3? 1. How many hydroxides do I need to get to a 3? 3. That means I have AlOH. I have more than one, so I have to put it in parentheses. 3, and that is my aluminum hydroxide, and we are at the end. Sehr gut. See you next time. Ciao, belle.